All right, so let's start with data. What is data? It's information coming from, yes?
Can I borrow a pencil?
Oh, you know what? I don't actually use pencils, so I don't even. I don't know if I can let it here. Let him in. Somebody want to hook him up? Yeah. Thank you. All right. So data is information that comes from observations, counts, measurements, or responses. So our job in statistics is going to be to do something with that data. It can be interpreted by a human or a machine to derive some sort of meaning. So when we say machine, we mean like a calculator or a spreadsheet, or us just running information by hand. Good. All right. Statistics is the science of collecting, organizing, presenting, analyzing, interpreting that data. So that will be our job for the next 16 weeks, is to take data, to do something with it, and hopefully make it meaningful in some way. Okay. All right, so first pair of definitions that you're going to have to be able to tell the difference between are population versus sample. Population means everything, everyone, all. So you're going to look for keywords like that, like all, showing up if you're determining if you have a population or not. It is all outcomes, responses, measurements, counts that are of interest for whatever we're collecting data for. A sample is a subset of that. It is not everyone. 99% of the time in statistics, we are dealing with samples because often to get a population is tedious, time-consuming, difficult, maybe costly. So imagine like trying to get even like a U.S. census, for example. So we call it a census because it's everyone, so it should be a population, but it's really not, because does every person in the United States fill out that form? No. So it's really a sample of the entire population of the United States. Okay, so population versus sample. Population's everybody, sample is some of the group. Okay. All right, so the first thing I have for you guys to practice with this is this. Okay, so find a friend if you don't have one already, and I want you to determine if each of the following data sets are populations or samples. Go. All right, let's talk about this problem. You don't have to write it down. It says in a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of those 834 respondents, 517 said yes. We want to identify who is the population, who is the sample, and then describe the data set. All right, so starting with population, that's the largest group. So population is not necessarily who is being surveyed. It's the group that those people are coming from, the larger group. So it is employees in the United States is my population, okay? The sample is the group that is selected to get that data set from. So who is my sample here?
834.
Perfect. It is the 834 that were asked the question. And then finally, the data set, think of the data set like your results, your numbers that we'll eventually do calculations with. So the results were 517 said yes. And we don't know what the other people said. We don't know if it was a yes, no question or maybe or whatever. But that would be the results, the data that we got from that sample. Does that make sense? Okay. So back with your groups. I want you to do the same thing for these three sets of information. I want you to tell me the population, the sample, and the data set. Okay. Okay, if you did not write something on the board yet, you're going to put something up now. I will let you claim whatever you want to claim. Households are the population. The sample is the 1,353 that were surveyed, and 78% of them own a computer. In the middle, elementary school children, all elementary school children is our population. Sample, the 2625, the data, the 28%. Again, that's good. At the bottom, population is people entering the mall within those 3 hours. And that's kind of what we can gather, our best guess from the information we're given. Statistics is a little bit different than other math classes where, like in algebra, I mean, X is 3 if it's 3, right? There's no other answer, there's no gray area. Statistics, I mean, the population maybe could be like people in that city, or people visiting, or it could be people that were there all day long. We don't know from what we're given there, so we just make our best guess and hope it's close to what's actually happening there. And then the sample is every 6 person, and then the data is within that 3-hour period. The average weight was 146. Okay. Any questions?
So like for the population, if it makes sense, it can be right.
Yes.
Not everyone might have the same answer.
Yeah, I mean, we're going off of a single sentence of information. If you were actually going to design like an experiment or a survey or an observational study, like you would have paragraphs upon paragraphs describing exactly who is your population, who is your sample. We're just gathering what we can from that little piece of information right now. Okay. Any other questions on that? Okay, cool. Alrighty. So next definition, parameters versus statistics. A parameter is a number that describes the entire population. A statistic is a number that describes a sample. And it's easy to remember because they start with the same letter. Parameter, population, statistic comes from a sample. So again, most of the time we're going to be dealing with statistics because we do not have information about an entire population. All right, so example at the top of a parameter is all 100 senators in the 109th Congress are analyzed, observed, whatever, and we find that 55% of them are Republicans. Example of a statistic, in 1963, Literary Digest polled 2.3 million adults, and 57% of them said they would vote for Alf Landon for president.
Bless you, brother.
Bless you all. Okay. Okay, so population parameter, sample statistic. Good. Got it? Okay. All right. So let's do this one together. It says, decide whether the numerical value describes a population parameter or sample statistic. It says the 2,182 students who accepted admission offers to Northwestern University in 2009 have an average SAT score of 1,442. So the data that we're getting here is that the average SAT score is 1,442. Does that average represent a sample or the population in this case? It's actually a population.
Population.
Because the population here is students who accepted admission offers. Now, you could maybe get a little more information. Maybe you knew that other students at Northwestern who were not accepted were also included in the survey. But from the way it's worded, the 2,182 are all of a group. They are all of the students that accepted admission. So because it's based on that population, we call this a parameter. Okay? Mm-hmm.
So in a parameter, there's no sample you can like pick out from it?
Now there are samples we could pick out from it. I mean, we could do more calculations with this. Maybe out of those 2,182, then 100 of them were surveyed and found that their ACT score was a certain. So we can still find a sample from that. We can still find a sample from that, but we're just looking at this specific survey or observation. Was it from the population or not? Does that answer your question? Okay, so let me do the other one that was on here that I kind of jumped over. A lot of times you're going to see like a keyword pop up, like this one. It says in a recent survey of a sample of college career centers. Okay, so that's telling me it's not all the career centers, it's a sample of the career centers. So therefore, this information about starting salary for engineering majors being $83,000 would be a sample statistic because it's based on a sample of colleges. Okay? So with your friends from, oh, do I have any more of those? Oh, I don't have any more of those. Oh, well, that's all right. We'll do our last definition, I guess. Descriptive and inferential statistics. So descriptive statistics involve organizing, summarizing, displaying the data. If you have probably done anything with statistics before, you have probably done descriptive statistics. You do your calculations like mean, median, mode, make a histogram, box and whisker plots, lines of best fit. Those are descriptive statistics. Inferential statistics involve using what you get from that sample to then draw some conclusion about the population. Because remember, statistic means it's coming from the sample, and ultimately that's our goal. When we take a sample and we ask them questions or calculate data from them, we're trying to make an inference about everyone. Maybe I survey everyone in this room and ask you a specific question, and my goal there would be to then make an inference about all high school seniors or all Jackson High School students, possibly. And we'll talk about in a few sections from now ways to gather good sets of data and ways to gather biased sets of data. For example, if I wanted to ask all of you a question, it would probably be biased because number one, you're all pretty much in the same grade. Number two, you're all taking CCP classes. Number three, you're all interested in statistics. So just those three pieces of information alone make this a pretty biased group if you're the only people I ask that question of, whatever it is, okay? All right, so descriptives involves doing the calculations, organizing, sorting. Inferential means making that inference, making that jump. Okay, so with your friends, you can do this one. Determine if these three represent descriptive or inferential statistics. Go. The first one. Descriptive, right? There's no result or inference being made at the end there. We're just stating the numbers. The middle one, inference. You see that word concluded? That's a pretty big clue that that's what's happening there. And then the same thing with the last one. A study has concluded, so it's going to be inferential again there. Okay, so descriptive, inferential, inferential. Questions there? Okay, last slide I have for you. We're just going to kind of talk through this one real quick. It says, for each study, identify the population and the sample, then determine which part of the study represents the descriptive branch of statistics and what conclusions can be drawn from the study using inferential statistics. Okay, so the study is 300 Wall Street analysts found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. Who's my population? My population is all Wall Street analysts. The sample is 300 Wall Street analysts. What here is representing the descriptive branch of statistics?
just like, there was a study with your analysts and the forecasted high-tech earnings and research.
Yeah, that second piece of the percentage who incorrectly forecasted the high-tech earnings, 44%. So that's our data. That's our results of our survey, or whatever it is. And then what conclusions can be drawn? So this is where you can kind of take a leap. So if you looked at the findings of 300 analysts and you found that 44% of the time they were incorrect about their high-tech earnings, forecasting the high-tech earnings, what would you conclude from that piece of information?
Most of the time they're right.
Most of the time they're right. Are they right more than they are wrong? A little bit, but not much, right? My first period actually said they should be fired if they're only right 40% of it. Because if you randomly guess, you should be right how much? 50% of the time. So 44 is like not so great for them. Okay. Any questions? That's it for 1-1. We're done. All right, so your 1-1 Math Excel is due Tuesday night. Honestly, it's super quick, guys. You can probably get it done in class today if you're really motivated. All right, and I'll do cell phone lotto. The rest of the period is yours.